So here we're going to try to explain the octet rule. Now, what is the octet rule? Actually, the octet rule is something that can help us understand more to explain the honk 1, 2, 3 rule. Sorry, honk 1, 2, 3, 4 rule. Now, what is this octet rule? Basically, it says that all atoms seek to have a full valence, so outer shell. Let's look at our examples here. So hydrogen wants to look like helium. What does that look like? Well, the Lewis dot structure says that hydrogen has 1 dot and helium has 2 dots. So this dot is an unpaired electron. For every unpaired electron that we find in our Lewis dot structure, that electron wants to have a bond. So with one unpaired electron, it wants 1 bond. Okay, so that bond, if we get another electron put into this place, then we would get a bond. And we can get that electron by sharing it with another atom. So let's take a look here. We have number 2, we've got oxygen. Oxygen wants to look like neon. And oxygen has a Lewis dot structure that looks like this. 1, 2, 3, 4, 5, 6. So it wants to look like neon with our 8 electrons. And what do we find? We have 2 lone pairs. So the lone pairs are up on top and down on the bottom. And then we also have 2 unpaired electrons. So for every unpaired electron, we want 1 bond. So with 2 unpaired electrons, then we want 2 bonds. And that's starting to follow our honk rule. Taking a look now at number 3, we've got our nitrogen. Again, that wants to look like neon. But this time we've got 1 lone pair of electrons, wanting to look like neon here. And then we've got 3 unpaired electrons. So with our 3 unpaired electrons, we want 3 bonds. So last in the honk rule, but certainly not least, is our carbon. Carbon again wants to look like neon, but this has 1, 2, 3, 4 electrons. And so that means we have 4 unpaired electrons. And we have 4 bonds. So that is our honk 1, 2, 3, and 4 rule.